Coastal Soda Sales have an exclusive market right, which means that they can set whatever price they want. There's no competition. They have a demand function, so a price relationship for the price and the number of sodas. And then they have a cost function. Determine the revenue function. So revenue, price times units. That's price, which we have an equation for, times units, which is x, which means the revenue function would be 2x minus 0.0004 x squared. And then, of course, we have a cost function given, 600 plus 0.2x plus 0.0001 x squared. What would the profit function be? Profit is revenue, take away cost. So the revenue function, 2x minus 0.0004 x squared, take away parentheses so that the negative gets distributed through the cost function. And WebAssign doesn't really care if you simplify it. You could put it in this unsimplified format, but I'll go ahead and simplify it. Just distribute the negative through and combine like terms. Negative 0.0005 x squared plus 2 and negative 0.2 is 1.8 x and take away 600. X minus 0.004 squared. And then profit is that revenue, subtract, in parentheses, around the cost. And as long as there are parentheses around the cost so that WebAssign knows that the negative would have to be distributed, it should take it in that format. Oh, except I missed a 0. Okay, let's try it again. Okay, now, what profit maximizing price per soda? So I want to maximize the profit. So let me go into Excel and set up some columns. We'll have X be the units. And then I have a price function. Let me just start with 100. Price is 2 take away 0.0004 times by the number of units. And then there's, from that we can make the revenue, price times units. There's a cost function provided, which is 600 plus 0.2x plus 0.0001 times, get the units and square it. Neglected to do that right there. So times, get the units. And then finally, I can build the profit function from revenue, take away cost. So 100 sodas is not profitable. Let's get some more data in here. Copy our formulas down. Okay, better. We're losing less. So let me expand the data. Profit's going in the right direction. There we go. Positive profit and constantly going up. Where would the maximum happen? It looks like somewhere past 1400. Let me expand the data a little bit more. Still not. Okay, there we go. So right now it looks like that is the maximum that I can see, but I'm jumping by 100s in here. Let me take this last row and pull up Solver and just double check to find out where the maximum happens. Set the objective. The objective is my profit to a maximum by changing the number of units. No constraints at the moment, except I don't want a negative number of sodas. And 1800 was the maximum, and they wanted to know what was the price per soda that would maximize the profit. And it looks like $1.28. How many sodas would expect to sell at that price? That's 1,800, the number of units. And what would be the daily profits? $1,020. Okay, now the festival organizers want to set an economically efficient price of $1.25 per soda. So now there's a constraint. How would that change everything? Well, let's pull up Solver again, and we can put in a constraint. So I'm still maximizing the profit by changing the number of units, which is this one, yes, subject to the constraint that, let me add a constraint, the price has to stay less than $1.25. And hit OK. Cancel that last one. Yes, I hit add twice. So there's my constraint and ask it to solve. With the price difference, then now the sodas it would expect to sell is now $18.75. So more sodas at a smaller price. Profit would go down, but only $3. So $10.17 and 19 cents. This is my profit. Would Coastal be willing to provide the sodas? Yes, because the profits would be significantly greater. No. Yes, because the profits would be almost the same.